Hello?
Hello.
Hello.
Keep the lights off. Are you gonna throw blueberries at us?
Probably.
Most likely.
Can we throw it at Alex? Are these new ones?
We're not
All right.
sitting on the phone with them.
Yes.
Okay, so now, okay, I'm gonna try to break this up as much as I can. We have 130 minutes of class, and I know we cannot do 130 minutes of instruction.
Why not? You could.
Can we take
Just
a break?
finish all the 6.1 notes.
I'm trying to, but it's broken up into many parts. So I'm gonna do a little bit. I'm gonna stop the video, then I'm gonna do some more. Okay? I'm gonna give you guys time to actually work on some of these problems. All right, so let's take a look at what we have here. Finding the area between graphs formed by partitioning the y-axis. Now, when we're talking about partitioning the y-axis, I'm now going to be using a dy. So I'm going to be everything in terms of y. So I should get my function, which would be like an x equals. And if you notice, my bounds now are no longer on the x-axis. The bounds are on the y-axis here.
It's just like a reverse.
Kind of. So we would actually do, since it's from here to here, this way, my top minus the bottom. Okay, top minus the bottom. So I have to look at it. So it's going to be the parabola here in pink over the parabola in red, or not parabola, whatever wave that is in red here. So these ones, so I'm just trying to find that specific piece. So whenever I'm doing something like this, it's going to be the graph from C to D of f of y minus g of y dy. All right, so find area A, the region enclosed by the graphs.
We did this example already.
We did?
Yeah, what? We can do it again.
If
Do you want to do it again?
No.
Yeah, why not?
No. I have a yes and I have a no.
The-
Anyone else?
Maybe.
I have a maybe, so that's like
Yeah.
halfway between.
50-50.
Huh?
What notes are these?
6.1. We did these a while ago. Do you want me to do it again?
No,
Okay, let's do it again. All right. All right, so now my x equals f of y, right? So if I were to take a look at this, and so it's going to be a y squared, so that's going to be a parabola opening. So let's take a look. So if it's enclosed by these two, I know that these two are going to be equal. So let's say y plus 2 equals y squared. They're equal to each other at some point because they're enclosed by each other. So go ahead and move everything to the right, so I get 0 equals y squared minus y minus 2. And then I try to factor that. I factor my trinomial. 0 equals parentheses y plus 1 and y minus 2. So it's going to be y is equal to -1 and y is equal to positive 2. So that gives me my bounds. So in those bounds, that means that they are going to intersect. They are going to be equal at those two places. Now, given that, I need to know which one has a larger x value inside there. So I pick a numbers inside there. So let's take a look. You want to pick 1? We can pick 1. I like 0.
Yeah, zero's the easiest one.
Zero's here. This is going to give me, so this one will give me 0, this one will give me 2. So that means that this one right here is going to be on top of this one right here. If you put 1, it's going to be 3, and it's still going to be more, right? Okay, so this one's going to be the top. So I have my top minus my bottom. So it's going to be the integral from -1 to 2. And so a top minus the bottom, so it's going to be y plus 2 minus the bottom, which is going to be y squared, and all this is dy. So I can separate it into two separate integrals, or I could just have it combined in one integral. So let's go ahead and integrate. So it's going to be y, okay, so y squared over 2 plus 2y minus y cubed over 3 from the bounds of -1 to 2. Okay, let's do the math now. Top minus the bottom. So the top is going to be 4 over 2, which is 2, plus 4 minus 8 over 3. There's the top, minus the bottom, which is going to be 1/2 minus 2, and then minus 1 over 3.
I
I
think
think you're allergic to math.
Sneezing.
allergic to math.
I don't think we can do it.
Oh, I know, I can't do it anymore. Alright, so go ahead, we're gonna math all this. Common denominator is gonna be 6. So it's gonna be 12 over 6 plus 24 over 6 minus 16 over 6
Isn't it minus 24?
minus 3 over 6 plus 12 over 6 and plus 2 over 6. So,
Isn't it minus 24 over 6?
why would it be minus 24 over 6?
6 minus 8, sorry. And you change it to 12 over 6 minus 24.
Okay, what's 12 divided by 6?
It's gonna be.
Say 2.
Oh, okay. Yeah, I think you added those.
Okay, yeah, so, yeah, you haven't added it yet. Alright, let's put it all together. So, let me see, I'm gonna have 36 over 6 minus 16 over 6 is 20 over 6. 17,
17, 29. 31 over 6. It's 31.
29, 31 over 6. Did you guys come up with 31 over 6? Did we get 31 over 6 last time we did this? No? We didn't finish?
No,
Okay.
we got 27 over 6.
27 over 6?
Excuse me? I don't write notes.
I know, so that's what I'm asking. You know, is y'all got this thing on your desk? It's called a calculator. So
It is
Yeah,
21
last time I
over
got
6.
27 over
It's
6.
fine.
27 over 6?
Calculator, yeah.
Okay, so it's supposed to be 27. So we did a little math wrong. So I was listening to Bo here.
Where? That doesn't make sense.
I don't know.
36,
Honestly, maybe. There's no.
17,
Check
29,
it.
31. It is 31.
24, 12.
Yes, 31. I mean,
Because it was supposed to be
Ah.
minus 2 over 6.
Why?
That's what we.
There's minus before brackets.
it's negative 1/3. No, it turns positive.
Oh, because we had here, it's positive 1 over 3, like in my notes, and then you have negative 1 over 3 in your thing.
Did I not do the sign right on last time?
Yeah, you didn't.
Yeah,
have
I think
this.
Okay, yeah, so I messed up last time then. So it is right, 31 over 6, right?
Wait, does the calculator say 31 over 6?
Yeah, I got 31 over 6. I didn't use the calculator last time.
Good job, Pancho.
You know what? Everybody makes mistakes. Everybody has those days.
But you're a math teacher, so you're supposed to always be right.
No, he's under Rob.
You know what? I'm wrong so often.
That it should be right.
Make sure you do your notes.
First of all, I don't have any cash. So
Taking a-
okay, sure, I'll go just the Walmart and buy one for $3. I don't care about you using the zero.
the shape of like a freaking giant egg. Because I'm round like this.
2 plus 4 minus 8/3 minus half plus 2 minus 1/3. Should be minus 1/3. Where did I miss that?
Oh, you missed that because you plug in -1 to the y third and it's gonna.
There we go. Yes, yes. Okay, so yes. Okay, so this should be a plus sign. That's why.
Why do you keep doing this to me? I told you.
Because just.
So we were going to go back to.
Yeah, I was right the first time, so. Okay, that's what I'm double checking. Make sure I don't screw up. I don't want you guys to be all messed up.
Oh,
Now
got the
then,
idea
it
of
should
the
be
thing.
minus 2.
And then this should be, yes, minus 2/6. I'm trying.
No, I didn't. It's not my day. My cousin did. It was there. It was like on the side with the shell. And I put 2 shells in it.
There we go.
No.
All right, so this thing right here is the graph. This thing right here is the graph. You guys have the slide.
Yeah.
It is the graph of what, so you guys can see where you get this y and where we're doing this from. So my bounds are supposed to be from -1, which is here, to right here, and top minus the bottom. So it's only going to give me this piece right here in the inside. Find area of the region enclosed by these two right here, and the x-axis by partitioning the x-axis, then partitioning the y-axis. So to do that, if it is y equals, how am I going to do that one at first?
Like, no, first like it's asking by x-axis. So
X-axis. So I'm going to partition the x-axis. So let's take a look. So I'm going to get y equals, actually let's just jump straight to the equals. So equals right, so we get that. Yes? So we set them equal, what goes from there? We gotta try and get x by itself, right?
Yeah.
So what am I gonna do?
Square both sides.
Okay, so I get 4.
Minus 4x equals 4 minus x. Then it's gonna be 0. X is 0.
So over here I get 0 equals 3x, right? So find the area enclosed region of there. So now that gives me some issues, don't I?
I only want one.
Is that really true? Let's take a look. Let's try see what the calculator says for this. So we have square root of 4 minus 4x, right?
Actually, we're losing one of the roots because there are 3 points. Because we have to tell that square root of 4
Doc
minus x is
B.
more or equal than 0.
Right here we have,
Or you don't listen.
I am listening, 4 minus 4x, right? Yes. So hit enter. And then the next one's going to be
Square root.
square root of 4 minus x. There we go right there. So, what does that tell me there now? It does only intersect one time, doesn't it?
Yeah.
But why does this stop right here?
Because square root has to be more or equal to 0.
It has to be greater than 0, right?
Yes.
So each of these has to stop here. So if I were to do that, so they're equal at 0, so that took care of that. But then these things does not exist at other points. So let's see, where is this one going to be equal to 0? So I cannot have, so for this one, 0 equals square root of 4 minus 4x. Square both sides, so 0 equals 4 minus 4x. So I get negative 4 equals negative 4x, so x is equal to 1. Okay, that takes care of that. So that's the place in which that x has to be what? Less than
Right.
less than 1, right?
Yeah.
X has to be less than 1. So if I put numbers that are greater than 1, this is imaginary, right? Okay, so there's that part. So let's do the other part. 0 equals 0 equals square root of 4 minus x. 0 equals 4 minus x. Negative 4 equals negative x. X is 4. Yes? Okay. So now are we ready? We're ready now, because I now know what goes where, right? And this one goes further out, so this is going to be a bigger bound, right? So they intersect at 0, and then this stops at 1, so it's not going to work from there. So what I have to do for this problem, since I have, this one is going to be, so I'm going to erase these right here so I could show you guys. Now, I'm setting it up. I'm going to have an integral. Now, I'm going to do top minus the bottom, but the problem is the first one doesn't exist after 1, right?
Yes.
It doesn't exist after 1, so I can't really do the integral of top minus bottom if it's not going to exist there. So I can't really plug in numbers where it don't exist. So my new bounds are going to be starting at 0, because that's where they both intersect at, right? And it goes to what value? 1. It goes to 1. Very good. And it's the top minus the bottom. So it's going to be square root of 4 minus x dx minus, okay, I'm sorry, area is going to be plus. So that's going to be that plus. Now, my next bound.
From 0 to 4.
From 0 to 4?
From 1 to 4.
1 to 4. 1 to 4 because,
I've been trying to find it.
yeah, hold on. I was right the first time. Minus 0 to 1. I am not having a good day today.
Yeah, you had to do first from 0
Yeah.
to 4 and then.
Okay, so that's going to be my first bound. That is going to be in my graph. If I can pull up my graph here. Nope, can't pull it up. So, from my graph, so it's going to be top minus the bottom. So it's going to be just this piece right here, here to here. And the next one I have to have, because I have to go all the way to here.
Yeah, we have to.
So now it's going to be plus
What?
integral from 1 to 4. 1 to 4 of, right here, 4 minus x dx.
Isn't the enclosed area is just between 1 and 4 on the graph?
Do they intersect again?
No, but if we can say, don't we use like the x-axis as the intersection?
Yes.
Yeah, so
But
it's
the-
gonna be this like piece, isn't it?
Yeah, but.
So we,
Hello?
Hi, are you guys doing testing stuff?
Not really.
Okay. I just had a question.
1 second, what's up? Okay, so since these ones only intersect one time, that's the reason why I'm doing that. So, because it's actually going to be the bound to the x-axis. No? No.
I mean, so we just like, can you turn the graph back on, like the picture?
Yeah, I'll show you. Hello. So watch. I'm gonna do menu, analyze, bounded from 0 to 4, right? Uh-oh, it's undefined to there. Let's see, why is it undefined?
Because one of them doesn't exist.
So I have to go from here to here, right? Menu, analyze graph, integral from 0. Alright, hold on.
Yeah, but then we need just find that part like from that point where it intersect and down to the 1 and 4, or between 1 and 4. That curve is here.
0, enter, and then, because this one does not exist after this, right? That's the reason why I have to go to 1, enter. So we have this piece right here. We have that piece. And now I have to go menu, analyze graph. Okay, and now I'm just going to do an integral from 1 to 4. Dang it. Doesn't like me. Okay, so. No!
I just saw we have to find the area of the, like.
Okay, so now, menu, integral, this graph, oh, there we go, 1, enter, 4, enter. There we go. So we have both pieces, but we have to do it as separate parts, because my first one does not exist.
Yeah, but I said that we need to find that all that shaded area which is on the graph now, but we have to find all of them together, because that's gonna be between them. Isn't it between them?
It's from here to here, right?
Yeah, I mean like, why won't you find the whole like gray area which is there?
Because it's undefined there, you can find, because.
We can like find the integral from 0 to 4 of the red line and then minus the integral from 0 to 1 of the blue line.
Yes, it could do that, but it's going to be,
Like this small-
it's the exact same thing that we just did here.
well,
But here I did top minus the bottom. You're just arguing the same point though. Here I just did top minus the bottom with the same bounds, and then I did from here to here. You're saying go from 0 to 4, right?
yeah,
And then minus 0 to 1 of my other bound.
yeah.
Yeah, it's the same thing. I'm just trying to set it up.
Okay.
Okay? Alright, so to be able to do these integrals, what do I have to do with the integral? Okay, what type of rule? If I was to take the derivative of that, what would I use? Chain. So if I'm using a chain, what does that mean? Whenever I have chain, what type of integration do I have to do?
U?
Yes, U. Did I have that right, or did I put it backwards? No, it's 4 minus x. Dang it. There we go. So let's go ahead and do my u sub. This is going to be a u sub for my integral. So u, 4 minus x, so du, negative, negative what? Dx, very good. Alright, so I'm uing all that's on the inside. So it's going to be a, let's see, negative integration from 0 to 1 of u to the what power? 1/2. And then du. And let's do the same thing for this, right? So here u is equal to 4 minus 4x. Du is equal to negative 4 dx. So now it's going to be, so if I'm taking out a negative, this is now going to become a plus, right? Say yes. There's already a minus sign, right? And so it's going to be a plus integral. Okay, so 1/4, right? Of u to the 1/2 du. Yes? Plus, okay, so this again, hold on. U equals 4 minus x du is equal to negative dx. So I'm going to take out that negative. So again, that's going to change my sign here to become a minus sign. And it's going to be integral of, let's see, 1 to 4. And that's going to be u to the 1/2 du. Oh, I didn't put the bounds. Thank you. So we could use sub my bounds, or we could just put it back in. So either way, if I use sub the bounds, it might be easier. Let's see. If I use sub the bounds, this would be, let me see, 0 to there. So that would be 4, would be my lower. Right? So if I'm plugging in, so 4 is my lower. And then plug in 1, it would be 3, right? Is that improper? It's improper, so that means I would switch the bounds and change the sign. Yes? Yes, maybe.
Yes.
Okay, good. I'm starting to get worried. So again, let's do it for this. I'm going to use sub my bounds. So plug in 0 here, I get 4. Right, because I'm plugging in 4 for the x. And now I'm plugging 1. It's going to be 0? 0. There we go. So again, improper integral. I'm going to flip it and change the sign. Do it again. So it's going to be my bounds starting at 1 would be 3. And 4 is 0. Another improper integral.
Just change the sign.
So change the sign, right? So all of them come out to be improper integrals. So I'm going to change the sign and flip it. Okay, so let's go ahead and do my math. So this is integral. That would be what?
2 over 3 u to the 3 over 2.
Yeah, u to the 3 over 2.
Over 2.
Right? And remember, we're changing the bound. So this is negative first. Now I change it, so this is going to be a positive, right? Positive from 3 to 4. We're going to do the same thing again for this one. So this is going to be, there's a 1/4 out front already. So this is going to be u to the 3 over 2. And it's going to be 2/3, right? But that 2/3 has to multiply by 1/4. It's what?
2 12s.
2/12, which is
1 6.
1/6.
Negative 1 6.
So it is 1/6. 1/6, and since I'm changing the bounds, okay, I'm going to flip the bounds, so now it's going to be from 0 to 4 to make it a proper, and then this is now minus. Last one over here, it's going to be u to the 3 over 2, and then it's 2/3. Now, switching the bounds, 0 to 3, so that minus sign is now turning to a plus sign. You guys can go ahead and calculate this, right?
Where do you find the integral in the calculator?
It's next to the book.
Okay.
Yeah. Are you just going to put it in the calculator, or are you going to do this part right here? Just entering, because my only issue here is because I'm going to have
I think it's easier just to put the integrals in.
I'm just going to have the square root of 3. That's going to mess up my decimals. So let me see, that's going to be 2, 8, 16 over 3 minus 7, 9, 3, 6, 2, 2 radical 3. This is going to be a minus 2, 8 over 6, which is 4 over 3. And then plus 0. Then plus, that's going to give me, let me see, that's going to be 27, 3, 3, goes away, 2, right, 3. So, I should come up with, ooh, hey, that's coming out pretty.
12 over 3.
Yeah, 12 over 3.
What is 4?
Answer is 4.
Are you sure?
Yeah.
It's faster than calculator.
No, I just did, I just
Me
did,
walking.
I just deleted everything, it was typing it in and
It's faster than
deleted. I was going to.
It's efficient.
Faster than a Ukrainian guy with a calculator who doesn't know how to use it.
Okay. You know, a lot faster than the guy in Moldova. He still hasn't picked up the calculator. True.
I mean, I don't even know how to, like on the test, when there was that pre-response second parallel calculator, I don't know how it's half an hour enough to do all of those.
It is.
It is not. It's like, I don't know. How?
if you were using the calculator.
You didn't know wrong answers.
Excuse me.
Like, I'm pretty sure.
Huh?
That's not supposed to be like that. Just check.
Yes, I am.
Oh, did you change the bounds?
Uh,
Oh, you changed the
Yeah,
bounds, so you
four.
don't have to put that back.
Good job, you did.
Because when you use sub the bounds. Okay, what we did is by use subbing the bounds, I don't have to plug it back in.
Oh.
If I left it with the original bounds of 0 to 1, I would actually plug this back in for my u. But now, since I'm use subbing the bounds, I don't have to. It's one extra step that I don't have to do. I don't have to put 4 minus x back in there. Because I'm just going to change my bounds. So I put this number in here. So 0 goes here. So that gives me u4. My lower u bound is 4. So that's where I change that. And then I do the same thing for the top, which is going to give me 3. So my lower u bound is 3. Or my upper u bound is 3. And so now I no longer have to put this one back in.
So then how are you getting like the 16 over 3?
Okay, so for the first number, okay, so remember the bottom number in a fraction, like the exponent, is always a root. So this is square root. What's square root of 4? 2. What's 2 to the third power? 8 times 2, that's already out there. 16 over 3.
Oh, okay.
That's where we get that.
And then you just do the next one was with the
Yeah, but the problem is on the next one, it's not going to work out as well because it's going to be, I'm doing a little bit of factoring because 3 to the third, so I'm doing the power first, is going to be 27. 27 is 9 times 3.
Right.
Square root of 9 is 3, right?
Yeah.
And the 3 that I took out cancels out the 3 that was on the bottom. And then I still have a radical 3 left over. So that's where I get that.
You calculated everything right.
Alright, so
We did the y-axis. Yeah.
you ready to do the y-axis or do the break first?
Okay, can you please explain one thing?
Yes.
The, from 1 to 4, why does it only go to the second one? Like the second part of the...
Oh, yeah, okay, so I'm sorry, you might have missed it. Right here, when I was doing this in the calculator right here,
Yeah.
okay, so does this exist past this point?
No.
Yeah, that's why. So I'm gonna move, there we go. So, let me grab that point right there. So it doesn't exist past that point. So that's the reason why I'm only doing from this piece to this piece right here. Because the blue doesn't exist.
Oh, okay.
So that's why I had to break it up into 2 separate integrals. Does that make better sense?
Yeah.
Okay. So I'm going to stop this one. All right.
Is the screen on?
Hello? Okay, again, we're finishing up. We just got back from our break, and people are now going to follow along and pay attention again, right? Okay, so we did all this. We finished our thing. Now we have to partition by the y-axis. So I'm going to rewrite this on a new slide somewhere. Okay, so if we're going to partition this from the y-axis, I already did this once. So let's see. In the y-axis, so I'm going to look to see from here. There it is right there. So from here, my y-axis, what is my lower bound for the y-axis? What's the lower bound here? 0. And the upper bound will be? 2. Okay. So, if I'm doing that, which one is going to be on top?
Blue one.
The blue one, right? So I'm going to have the blue one. So it's going to be, let's see. So it's going to be the top minus the bottom. So it's the integration from 0 to 2 of the top, which is square root of 4 minus x minus actually, let me put in my dy here. dy, and then it's also going to be integration from 0 to 2 of my square root of 4 minus 4x dy. Now, I wrote it like this specifically, just so you guys can see what has to happen here. So what has to happen here with this? Are you guys even trying to pay attention?
No, I'm not.
Because I intentionally did this wrong. Because I know it's going to be the top minus the bottom, but what has to happen now?
Don't you have to change the function from x to the y?
Very good. I have to change the function from x to y. That's what I was trying to get at here. Because if I'm doing it in terms of the y-axis, it's going to be a dy. And so I need to change my functions also. So if I change my functions, I rewrite it as y equals square root of 4 minus x, square both sides. So y squared equals 4 minus x, subtract 4, y squared minus 4 equals negative x. X equals 4 minus y squared. So there's that function. Now I have to do the same thing for the other function. So if it's y equals square root of 4 minus 4x, so I get y squared equals 4 minus 4x, y squared minus 4 equals negative 4x. So, that's an x right there. So x is equal to, let's see, negative positive, that's going to be 1 minus y squared over 4. It's fine.
Wait, y squared over 4.
Yes.
Wait.
Okay, I'm rewriting it. So it's now going to be from 0 to 2. And so this one is going to be 4 minus y squared. Minus,
1 minus y squared over 4.
yeah, 1 minus y squared over 4. Alright, you still need the other page? Yes? Okay. So if I'm doing it in terms of the y-axis, I know that I need to have a dy. Okay, that's my delta in terms of y. That's the change in y. Is that a no? Yes?
No, she's so lame.
Yes.
Keep saying why because you're saying why. I'm like, it's like, stop. We get it. Like, don't laugh.
It's
You're
fine.
laughing, and so you're encouraging her.
No, because you're laughing.
I'm not laughing.
Laughing.
I'm not laughing, you're laughing.
Smiling.
I smile all the time.
Okay.
Not true. He's trying to laugh his dumb on side.
Yes. Alright, let's go ahead and integrate this. So if I integrate this, I'm going to get 4y minus y cubed over 3 from 0 to 2 minus y, right? And minus y, and this is minus y cubed over 12, right? From 0 to 2. Alright, so I get 12, actually let me see, that's 8 right there, minus 8 over 3, minus lower bound is just going to be 0. let's see, I'm gonna have minus parentheses 2 minus 8 over 12, which is,
So it's gonna be 4.
what's 8 over 12?
The answer is 4.
8 over 12, that's 2 over 3. Yeah, 8 over 12 is 2 over 3, yes? Yeah, okay, good. Alright, so it's that one, minus lower bound, which is 0. So I get 8 minus 8 thirds minus 2 plus 2 thirds. So I get right here, that is 6 and 6 thirds, which is 2. So I have 6 minus 2, which is 4. Same answer either way. So you can do these problems from both ways, just depending on what's easiest for you to try and do.
Okay. Yeah, so we got it, yeah.
Okay, there it is, and this is the graph of what it's going to look like. So delta y, right here, the change in y, so I'm actually just getting this area from here to here. Okay, so find the area of the graph, find the area A, region enclosed by the graph, y equals ln x, the x-axis, and the line x equals e. Okay, let's take a look what this is going to look like. So, ln x. What does ln x actually look like? So it starts down here, right? And at 1, it's 0, right? So it should look something like this, right? Okay, and then
X equals E is gonna be like 2 point something, just as
ln x, x-axis, and then x equals
so
E.
it is
That's e to the 1, which is like 2.7 or something like that?
Yeah.
E to the first, like 2.7. So it's in between here and here. So I'm going to do a different color to show what's going to happen. So enclosed by x-axis.
It's gonna be 2 different.
So that means it's going to be right here.
0.
So that's going to be one of the bounds. Okay, so that means it's starting here. Okay, the line x equals e. So there's no variable, so it's just going to be here. And so if it's bounded at the x-axis, it's going to be the line from here to here. So I'm looking for all this inside here. So that's how I'm trying to get it. So since it's bounded by the x-axis, that ln x is going to stop. Okay, so it's going to be starting at 0, right? When x is 1. So that's what I'm looking for. So this is going to be my enclosed area there. So let's go ahead and try and do the integral of that. So if I do the integral of that, it would be, let's see, I'm going to have the integral from 1 to e, right? From 1 to e, ln of x, and that's going to be dx. All right, your flashcards. Remember those cards I gave you?
Yeah.
I gave you more than one set, didn't I?
Yeah.
Yes, yes I did.
Jeez.
Oh, integral ln x. Isn't it gonna be just 1 over x?
Okay, so the integral, do you guys, on those cards, do you know what the integral of ln x is?
Let me check. Go into my cards.
the second set?
What do you mean?
I think it's on both sets. Integral of ln x.
Isn't it like e? I don't know. Isn't it 1 over?
Is it, are you sure it's
Not really sure.
I don't think it's.
Because I'm almost positive that I did give you the integral of that.
Almost positive.
So I thought I did give it to you. If I did not, this is one to write down.
No, it's
So the integral of ln x is going to be x ln x minus x.
X on X. That's very easy to remember.
And then plus c, right? But in this case, it is bounds from 1 to e. Now, if I did not know that, would there be another way of doing this? Say yes.
Yes. We can make.
Can I do this in terms of the y?
Yes.
I can do this in terms of y now. So I have now, if I do this in terms of y, so let's say y equals ln x. Let's do it in terms of y. So I'm going to e both sides. So this is now going to be e to the y equals x, right? Okay, so now I have changed my function. I can now do it as in terms of y, right? So in terms of y, let's take a look. Where does my bounds start? Where's my lower bound now? Okay. Where's it going to be here?
It's gonna be 1.
Say 0.
No, it's 0. This is 0. Yeah.
This is going to be 0, right? And then it goes up to some value right here.
Which is gonna be just 1.
Okay, so how can I figure out the value of this point right here?
Plug in e.
So I look to see, where is ln x equal to e?
That's 1.
Now 1.
So it's gonna be 1 from 0 to 1. To bounds. Then we can just find 0.
Okay, so now it's going to be integral now
From 0 to 1.
from 0 to 1. What's the top of this now going to be? e to the 1, right? So it's going to be e. Yes?
Yeah.
Because I'm looking at it sideways now. So the top now is going to be here, right? And I'm looking at it going this way. So it's going to be e
Minus e to the y.
dy, right? Minus 0 to 1. So I'm subtracting the other bound, right? Which would be my e to the y. Okay, so what do we get? So what's the integration of, is that a constant? E to the 1 is just a constant, isn't it? It's not a variable. So it would be E, right? EY, right? So it's EY, that's e to the first y, from 0 to 1, minus, and the integration of e to the y is e to the y. E to the y from 0 to 1. Okay, so now right here, this is going to be e minus 0, right? I'm going to erase part of this. Okay. So I'm gonna get, let's see, what do we said? E minus 0 minus E.
Minus
So it's gonna be 1, right? Minus 1? Minus 1. So from here, the e's go away, so it just gives me a positive 1. Let's go back to this one in black. I'm doing the same thing. So this is going to give me E, right? E, ln of E is 1, so that's times 1 minus E. Now the bottom is going to be 1. Okay, so minus the bottom, so it's going to be 1 times ln of 1 is 0, and then minus 1. So these e's go away, and then it gives me still the positive 1.
Is the area by x-axis and y-axis always going to be the same?
Yeah, if you can divide it either way, depending on what problems you have,
But it always.
it's going to get the same thing. So it depends on how complicated the problems are. This one, like I said, I thought I gave it to you on the flashcards. The integration of ln x is x ln x minus x plus c, but in this one it has bounds. All right, does that make sense or no?
Yeah.
Okay, like, share, and subscribe. We have like another chunk of minutes, like 20.